Hello, Jeff Zwerink again here with Give and Take, and this is the segment where we tackle those challenging scientific topics to equip you to be more confident as you go out and share your faith. Today I'm joined by Rana, a good friend and colleague, and we are going to ask the question, is genetic engineering a good idea? Fuzz, it's good to have you here today.
Jeff?
So this is just science fiction extraordinaire of ideas here. I mean, I can't think of the number of science fiction movies I've seen where genetic engineering has gone bad somehow.
Yeah.
So let's kind of just delve into that. Is genetic engineering a good thing? What are some of the good and bads that might come out of that?
Yeah, well, genetic engineering has progressed incredibly in the last decade or so. It's gone from scientists adding a gene for, let's say, insulin into the bacteria E. coli, where these bacteria would produce insulin that could be used for drug purposes, to now biochemists literally engineering complex metabolic pathways that involve 30 reaction steps to make very complex drug molecules.
So presumably that comes with a commensurate increase in understanding of what's actually going on in all of this.
Yes,
too,
yeah. So as we develop an understanding of biochemistry, and learning new techniques, you put those two together, and we have now very powerful capabilities of doing genetic changes on a large-scale basis for not only microorganisms, but even other organisms that would be more familiar to us, cattle and or plants and things like that.
Well, I know you've written a blog recently on your blog, The Cell's Design, where you were looking at a cancer treatment or a drug that could treat cancer that we use for some other way, and they were using genetic engineering to make this more available. Kind of give us a little bit of outline of what all was involved in that.
Yeah, well, it was a pretty elaborate process that these researchers went through, where they first of all had to understand how this particular compound was made in poppies that produce opium.
So it's a naturally occurring product.
It is.
Okay.
It's naturally occurring. And then they had to essentially piece together that metabolic pathway in yeast, one gene at a time. And they even had to combine that metabolic pathway with the metabolic pathway that produces dopamine in rats, because dopamine is one of the products, and they weren't quite sure how that was made in the opium poppy. So it was kind of a metabolic process that was pieced together from several different organisms. And then once they had that process in place, they had to tweak it and fine-tune it, control the differing levels of gene expression in order to produce high enough levels of this particular drug to make it commercially worthwhile.
Well, okay, so we're producing it in poppies, we're producing it in yeast. Why not just leave it in the poppies? Why go to all this effort to do it
because
in yeast?
Number one, poppies that produce opium are illegal, and so there's a lot of bureaucratic red tape.
Okay.
But the amount that you can produce with opium poppies is highly variable from year to year, and you can't produce enough that you would need to supply the worldwide demands for this drug. Whereas with yeast, you can grow them in gigantic vats in a laboratory setting or in a pilot plant setting, and produce huge amounts of this material in just a few days, as opposed to over the course of a growing season. So it's a much more efficient, more controlled, more reliable way of producing this compound.
So whereas the poppies would be off in nature, yearly time schedule for grow, you can grow yeast days if you want.
Yes,
so
it
really does scale up the amount of what you could have.
That's right.
Are we running out of this stuff, or?
Well, we're not running out of it. I mean, this compound is actually used as a cough suppressant around the world, but we're anticipating that this compound could actually be an effective cancer treatment, and so the worldwide demand for that compound is going to escalate beyond what we can actually produce.
So let's kind of step back. Obviously, there's some good things that we can do out of this, but we're talking about redesigning the yeast genome, if you will, correct?
Yes,
so
that's
we're
right.
putting in new things, taking out some. Isn't this playing God?
It is playing God. But I don't know that as a Christian I'm troubled by that idea of human beings playing God.
Explain that. We need more detail.
Well, to me, we're made in God's image, and because we're made in God's image, we can do things, though imperfectly, but in ways that reflect or mimic or image that the Creator's capabilities. And our Creator is a creator himself, so we are many creators. And when we create, when we invent, we are manifesting the image of God. We're the only
So this would be like, when we do art, when we build, or when we design things, when we paint things, when we compose music, we're reflecting the Creator. So you're just seeing this as an extension, another way of doing
That's
that
exactly
process.
right. That's very well put. And we also, according to Scripture, because we bear God's image, have dominion over the creation. So we have the right to use creation for our benefit or for the benefit of life on the planet. So the issue isn't playing God, really. The issue is, are we trying to take God's place? And those are two very different things. And I think we can do genetic engineering and play God without trying to take God's place. Now, of course, there's also that wisdom question. Is this a smart thing to do? Do we understand what we're doing well enough to avoid releasing some kind of catastrophe of biblical proportions, right?
Or at least all the sci-fi proportions.
That's right. But there are ways to actually engineer safeguards into the yeast, for example, so that they can't live any other environment than in a laboratory setting where you're using them to produce this particular compound. So if we have the knowledge to do this wisely and in a circumspect manner, and the question is, are we willing to do it that way? And I think for the most part, the answer is yes.
So kind of just briefly, as you look at all of this, do you see this as pointing towards a God or not?
Yeah, well, I see it pointing towards a God in two ways. One, again, is this idea that we bear God's image, so that I think points to the idea that human beings are exceptional, which lines up with the biblical understanding of humanity. But when you look at what it takes to engineer a metabolic pathway to make a cancer drug, it takes some of the best scientists in the world working in very large teams of 20, 30, 40 scientists who have to have enormous amount of knowledge to pull this off. They have to develop these very sophisticated strategies, and then on top of that, translate those into sophisticated laboratory protocol that require highly skilled people to carry it out under exacting conditions. It's very difficult to imagine how evolution could have produced a metabolic pathway when it takes that much effort on our part. If anything, this is evidence that to transform life from one form to the other requires intelligent agency and is a very powerful new kind of argument for God's existence and role in creating life.
I know genetic engineering does have this kind of boogeyman feel to it, but when you really delve into it, our ability to do that reflects that we're created in God's image, and it really provides very powerful evidence that the God of the Bible is the creator of all the life, and that should give us confidence that the Bible is an accurate reflection of what God has done and that we can go out and share Christ with others.